Welcome to Chemistry at Hononegah High School. I'm Brian Brown, and today we'll be looking at section 19.2, dealing with understanding pH calculations, how to calculate it, and how to get back to the original concentrations that it comes from. So what we're really looking at today is pH, and for this you're going to need a calculator handy. Now, if you remember from what we talked about yesterday, water autoionizes to form H plus and OH minus. And in a neutral solution, the H plus is always going to equal the OH minus. So in pure water, it's a neutral solution because these two concentrations are equal to each other. When we dissolve something in water, we might end up changing these concentrations or we might not through an equilibrium shift. Well, if we put something in water that has absolutely no effect on these two concentrations, it's still going to be neutral. But in an acidic solution, we added something that increased our H plus concentration and decreased our OH minus concentration. And therefore, we had an acidic solution when H plus was greater than OH minus. And a basic solution, it was the exact opposite. We did something that increased OH minus and decreased H plus. And therefore, we had a basic solution. So acidity and basicity are really tied to the concentrations of these ions, H plus and OH minus. Now, at 298 K, so room temperature, because in degrees Celsius, that'd be 25 degrees Celsius, which is what's considered room temperature. Pure water, the H plus and OH minus, both equal the same number, 1 times 10 to the negative 7th. So, at normal room temperature, these two concentrations not only equal each other, but they equal a billionth, basically, 1 times 10 to the negative 7th. Very, very, very small number. Well, if they both equal 1 times 10 to the negative 7th, when you multiply the two together, you get 1 times 10 to the negative 14th. This is one of our useful relationships that you're going to end up using for today's homework and the worksheet dealing with calculations of pH and so forth. So this is one useful relationship we're going to end up looking at. Now, remember when H plus increased, OH minus decreased, but the product is still going to always equal the same thing, 1 times 10 to the negative 14th. So even when we have an acidic or a basic solution and the H plus and the OH minus don't equal each other, they're still tied together. When one goes up, the other's going down by a very specific amount. And their product is still always going to equal 1 times 10 to the negative 14th. So since this is an equilibrium reaction, this relationship holds true for water under all concentrations of H plus and OH minus. So the product of H plus and OH minus is always going to equal the same number, 1 times 10 to the negative 14th. So if we know what our H plus concentration is, we can always calculate our OH minus. When we know what our OH minus concentration is, we can always find out what H plus has to equal using this equation. So this is one of our fundamentally important equations when we're dealing with acid-base calculations. So what is the OH minus if the H plus is 2.3 times 10 to the negative fourth? So we're going to put this exact idea to work. So here's where you're going to be starting to use your calculator with this situation. Now remember, the two have to multiply to 1 times 10 to the negative 14th, and that would mean 2.3 times 10 to the negative fourth times OH minus has to equal 1 times 10 to the negative 14th. Well, that would mean OH minus would equal 1 times 10 to the negative 14th over 2.3 times 10 to the negative 14th. So get out your calculator, take 1 times 10 to the negative 14th. Remember, don't hit times 10, that's your EE or EXP key. So 1 EE and then the negative key and then 14. Divide that by 2.3 times 10 to the negative fourth, and you get 4.3 times 10 to the negative 11th. So if we know one concentration, H plus or OH minus, we can always calculate the other by dividing that value into 1 times 10 to the negative 14th. So if you know H plus or OH minus, you can calculate the other. Because H plus and OH minus concentrations are small numbers, and people don't understand small numbers. Remember, if it's acidic, that means H plus would be greater than OH minus. And right here, this was our H plus, and this was our OH minus. Well, some people, when they look at these, have a hard time saying which one is bigger or smaller. Now, I hope that's not you. So I hopefully you realize that this is a larger value because it has a less negative exponent up here. But some people look at this bottom number and say, oh, 10 to the negative 11. 11's big, so that's got to be the larger value. So what this means is the concentrations we're dealing with are always going to be less than 1. They're always small numbers. And people have a hard time sometimes understanding numbers less than 1. So it would be nice if we had a method to simplify which one of these two is bigger. Because Believe it or not, many of your parents may have a hard time telling you which of these two numbers is bigger and which of these two numbers is smaller. And that doesn't make them any different from anybody else who doesn't practice and use these numbers all the time. So, because H plus and OH minus are such small numbers, scientists invented the pH scale to simplify these small odd numbers. On the pH scale, 7 would be considered true neutral. This is something you've typically talked about in middle school, in biology, in elementary school. So the pH scale is, I think, something you at least have a basic familiarity with. You might not be good at it, you might not remember it, but it's going to come back fairly quickly. Well, on the pH scale, 7 would be neutral, less than 7 would be our acid range, more than 7 would be our base range. Well, where do we get these numbers from? So where did pH 7 actually come from? And how come less than 7 is acidic and how come more than 7 is basic? But this is something that you probably knew prior to this class, is when your pH is 7, you're neutral, when it's less than 7, you're acidic, and when it's more than 7, you're basic. But where do these numbers actually come from? Well, where they come from is our two concentrations, H plus and OH minus. So they come from the actual values for the H plus concentration of the solution and the OH minus concentration of the solution. And remember, these two concentrations are tied to each other. Their product always has to equal 1 times 10 to the negative 14. But that doesn't still tell us where pH comes from. So where does the actual term pH come from? Well, since we're looking at something that helps us determine whether something is acidic or not, it would make sense that pH, which has this H inside it, and H has something to do with acids, that it should be related to the H plus concentration. Well, P in pH means the negative log of. And since it's pH, we're talking about the negative log of the H plus concentration. Anytime you see a P, so technically, I can have pH, I can also have POH, meaning the same thing. The P part of it means negative log of. So this would be the negative log of the H plus, and this would be the negative log of the OH minus. So P always means the same thing, negative log of. And since we're talking about pH here, that would be the negative log of the H plus. So literally, if I want to calculate pH, I would take the negative log of the H plus concentration. Now, for those of you with the graphing style calculator, which is most of you literally will plug it in your calculator in exactly this way. You'll hit the plus minus key, then you'll hit the log key, and if at that point it tells you error, then you don't have a graphing style calculator. And then you would plug in whatever the H plus concentration is. Hit equals, and it's going to take the negative log of that value, and it'll tell you then what its pH is. So this is our second useful equation here. So this is another thing you've got to be familiar with and know how to use. So how do we get pHs? Well, they come from H plus concentration. You just take the negative log of the H plus concentration. Now, if we have pH, and that's something you've heard before, well, P always means negative log of. So there's technically a base scale out there as well called POH. You just haven't heard of it before because it would make what's already potentially confusing to a middle and elementary school student even more confusing. So you've probably never heard of the pH scale or the POH scale. And that's because we've never really talked about the H plus OH minus idea before this because you haven't understood the chemistry behind it. And back in elementary and middle school, you may not have understood the numbers either in order to understand this application. But we do have pH, which is a negative log of the H plus, and we also have POH, which would be the negative log of the OH minus. So if I know H plus and OH minus, I can find the other, and I can also find their p values. And what you're really doing here is simplifying small goofy numbers to nice normal numbers somewhere typically between 0 and 14. And everybody can look at numbers between 0 and 14 and say which is bigger or smaller and whether you're greater or smaller than 7. So that's what we're doing is we're ending up simplifying numbers like 2.3 times 10 to the negative 14th and putting them into a more normal context that anybody can understand. So what is the pH if the H plus concentration is 2.3 times 10 to the negative fourth? Well, you need to remember that pH would be equal the negative log of the H plus concentration. So most of you, if you've got a graphing style calculator, you hit the plus minus key, then you hit the log, and then you enter that value. And then hit equals, and it should give you 3.64. If when you go to do that exactly as I said it, it gives you an error, then that means you have a simpler style calculator. And what you have to do is plug in your number 2.3 times 10 to the 14th, and then hit log, because it's going to take the log of whatever you have in the display. And then you're going to have to multiply it by -1, which you can do in the calculator or not. It's not really that big of a deal. But remember, there's two different styles of calculator that you're using. So depending on which style, you either hit negative log and then plug in your number and hit equal, or you plug in the number, then hit log and then make it positive by multiplying by -1. Either way, you should be able to get 3.64. Now, I'm going to mention this, but I'm not going to really take off for it. You'll notice most of the time with sig figs, we're not going to get too bent out of shape with log math. But the way it really works is the number of sig figs you have as a concentration is the number of decimal places you go to. So 2.3 times 10 to the -4th had two significant figures. So I'm actually going to go to two decimal places here. But if you put down as your answer 3.6, I'm going to end up giving it to you. So we're not going to get too bent out of shape with sig figs here. You just need to be able to essentially do it properly. Now, how do you find the original concentration if you're given a pH or a pOH? So we've talked about how to go from one concentration to the other. We've talked about how to go from either concentration to a p-value. But what if I know what the pH is and I want to get back to my original concentration? Well, there's got to be a way to do this. And since we're talking about doing the opposite, that must mean we're going to do mathematically the opposite. So to go to pH, we use the negative log of H plus. So we want to exactly undo that. So the last thing we did basically was multiply by -1. So now it's the first thing we're going to do here. So anti-log is the opposite of log. It is the 10 to the x key on your calculator. So that should be above wherever your log key is. So if you're hitting your log key, above that you should notice there's a 10 to the x. So for most of you, it's going to be a second function on your calculator. So if I want to find out what the H plus is, and I know the pH, I'm going to make it negative and take the anti-log of that. If you have a graphing style calculator, you're going to hit second log to get to the 10 to the x, and then you're going to hit the plus minus, and then you're going to plug in your pH, and then you're going to hit execute. For those of you who have the simpler non-graphing style calculator, you're going to take your pH, make it negative, and then hit anti-log. And if you have pOH to get OH minus, you do the same thing. Make it negative and take the anti-log of it. And remember, anti-log is the 10 to the x key on your calculator. It should be above the log function. So let's say our pH is 4.2. Well, I want to take then the anti-log of -4.2. Graphing style calculator, anti-log plus minus 4.2 hit equal. It should kick out 6.3 times 10 to the -5th. And remember, you may have to convert to scientific notation to see that's exactly what it's giving you. And notice that I really didn't pay attention to my sig fig rules here that I just talked about. If it goes to tenths, that's one decimal place. That should be one significant figure here. I still put it to 6.3 times 10 to the 5th. So just as a rule of thumb when you're doing this, go to one decimal place for your p-values and one decimal place for your concentrations, and that should always be good enough. We're not going to mark off for rounding on any of these things. So anti-log of -4.2 is where I got the 6.3 times 10 to the -5th. So how are pH and pOH related? Well, they should be related if everything else has been related. Well, it's actually one of the simplest relationships there is. It's one of the quickest and easiest to do. pH of a solution plus its pOH always has to add up to 14 every single time. So if I know what my pH is, it's really quick and easy to get pOH. And if I know what my pOH is, it's really quick and easy to get pH. So those two are probably the easiest type of calculation to do. You can often do those in your head. So if you notice, if I put my pOH values here and my pH values, notice they're always going to add up to 14. Now, as a review, so one last thing we're going to look at here is if I give you any of these four, you should be able to get to the other three using the relationships we just talked about. So remember, the most basic one, the easiest one is pH plus pOH equals 14. So if I know one of my p-values, I can find the other using this relationship. Once I know my two p-values, I can get to my concentrations using the anti-log. And remember, it's the anti-log of the negative p-value. Now, if I know my concentrations, remember I can get back to my p-values by taking negative log. And then finally, if I know H plus and OH minus, they have to multiply to 1 times 10 to the -14. So this is the relationship between all of the variables that we looked at. And you really have to be able to, at any one time, use 3 of these 4. You don't really end up using them all because you can get around using one. So most people probably use this one least often because it takes more to plug this in your calculator and it takes more to do it. But if I knew h plus, yes, I could quickly get OH minus by dividing into 1 times 10 to the 14th. But if I need to know them all anyway, I could go from here to here, and then from here to here, and then from there to there, just by hitting numbers in my calculator real quick with log and anti-log and so forth. So I didn't really end up having to use this relationship if I really wanted to avoid it. And it's, you still need to know it. You still need to be able to use it. But keep in mind, you can always get around if you're going from one of these to all of the others, really any one of the steps. So that is what we're doing on the second day of Chapter 19. Good luck.